Okay, hello. Who here is Cornish? Liars. No Cornish person is, or 3:15 on a Friday in a building. You are on the beach or in the pub. None of you can be Cornish. It is only me. Thank you for coming to my country. Please spend money. Please put it back into the economy. We need it. Why? People always laugh when I do that when I speak in Cornwall. And I'm like, it's not actually a joke. The taxi driver last night was like, please pay in cash. We need the money. Okay, so I'm Steve Smith. I know a lot about continuous delivery, and I'm going to talk about how you can measure it. I know everyone's a little bit demob happy, and I'm in a little bit of a silly mood. So who here thinks that continuous delivery is hard? Okay, thank you. You can stay. The rest of you, go home. You are wrong, okay? Continuous delivery is very, very hard, okay? And I'm going to show you some simple measurement techniques you can use to understand why it is hard and how you might progress on your continuous delivery journey. Okay, so I'm a person. I speak about continuous delivery. I'm writing a book called Measuring Continuous Delivery. It's on leanpub.com. I'm associated with Equal Experts, which is a network of independent software delivery experts now worldwide. Currently, I do 4 days a week at a retail client in London, and I do 1 day a week on DevOps. So that's the only time I'm going to mention that word today. Okay, so if I'm doing a talk, it's about continuous delivery, and it will probably start with the book. And in the book, Dave and Jez said, speed is essential because there is an opportunity cost associated with not delivering software. Okay, so continuous delivery is a set of principles and practices to help you improve the stability and throughput of your release process. But what does it actually mean to be doing continuous delivery? You know, do you have to be doing 15 deploys a day or 1 deploy a day? The answer is the classic consultant answer of it depends. Okay, you're in a state of continuous delivery when the stability and speed of your release process can satisfy business demand. Okay, so Sally's talk a moment ago about perfect software being a really bad idea, which I entirely agree with, was excellent. And at The Guardian, business demand for them means they have to be deploying all the time. Okay, but for other companies, it might be once a day, it might even be once a week, it might be longer. Okay, as long as you're working in a place where speed and stability mean that business throughput is the problem, it's not a technology impediment. Okay, that's the good place that you want to be in. Okay, when you don't have that speed and stability, you are in a state of discontinuous delivery. So who here is in a state of discontinuous delivery right now? My client is, yes. Discontinuous delivery is my invention. I am trademarking it. It is mine. I went to thesaurus.com and went crazy. There is also, of course, continuous disintegration, who someone mentioned on Twitter earlier today, and I am now also applying for a trademark on that before he does. So why is continuous, I will beat him. So why is continuous delivery hard? So it's for a couple of different reasons, okay? So first of all, there's an awful lot of technology changes that you need to make. Okay, so this is a list of changes that are in the book and subsequent books and some other things that I made up at my kitchen table. So let's talk about one of them. Okay, so database migrations. So who here is working in a place where database migrations are fully automated? Liars, too many liars. Maybe, okay, you're telling the truth. Okay, good. So it's pretty rare, right? And that's for a lot of different reasons. But when you come to implement it, okay, it's something that's quite expensive to do, right? It's going to take some time. There's quite a lot of risk associated with doing it. But if you do it and do it well, then there's a lot of value, okay? Think about where you currently work. If database migrations were automated, think about how stability and speed might improve for your deployments, okay? Now, these technology changes are made more difficult by the smorgasbord of tools that are out there, okay? Now, the good news is that it doesn't actually matter what tools you use unless you use one of the really bad ones, okay? So that I'm not even going to, it doesn't really matter, okay? You can use Docker, you can use Kubernetes, you can use Solaris zones, it's all fine, okay? Just don't use WebSphere, okay? Don't do that. Is anyone here from IBM? No, of course not. Why would they be here? Here before the flood, here after the rapture. Right, so on top of the technology changes, there are a lot of organizational changes that need to happen, okay? And each of these is more difficult, more risky, and more valuable than the technology changes, okay? So again, let's pick out one of these. Everybody doing on-call. Who here works in a place where everybody does on-call? Developers, testers, product owner, business analyst? Nobody. Where's Sally? Sally should bring her hand up. Sally's got a thank you, Sally. So I'm about to do it at our client, which I think is really exciting. So there's, again, a lot of reasons why it hasn't happened in the past, but think again about the changes that would have to happen, contractual changes, okay, positive incentives, communication channels between teams, maybe some team reorganization to make sure everyone's in the right place and has access to the right information. Okay, so that's going to be very challenging, but think of the value that you would derive from everyone sharing responsibility for the stability of your service in production. Okay? Now, it's not the technology and organizational changes that make continuous delivery difficult, all right? It's the application of these technology and organizational changes to the unique circumstances and constraints of your organization, all right? That's why continuous delivery is never repeatable. That's why it's different in every company. That's why I will never, ever build or sell you a pipeline product, because it's a waste of time. That's never going to be the big problem, okay? The big problem will be something about your organization, all right? Your organization is a complex, adaptive system in which every individual, including me, it has a limited amount of information, and the cause and effect of an event can only be established in retrospect, okay? So I haven't said the word Cynefin, but that, of course, is what I'm thinking of right there, and that's our time to Cynefin in 5 minutes. I'm doing well. Dan would be very pleased with me, but of course Dan was already on the way back to London, back to his Whippet farm. So given how difficult continuous delivery is, then how should we, his hat. So now I've distracted myself already, this is going very well. So how should you actually implement continuous delivery then, knowing how hard it is? Well, what you need to do is to continuously improve. You need to gradually improve the stability and speed of your release process until you can satisfy business demand. And the best way we have of doing this, everyone has pretty much agreed on, is to use the improvement charter. So who has heard of the charter? Yes, okay, good. We're going to be friends, okay? So the improvement charter has been codified by a guy called Mike Roffer. He studied the Toyota production system for a number of years in Japan, and then found that the main thing that was important, the thing that was really the unique thing that Toyota was doing, was this charter. Okay, so what happens is you have repeated cycles of a 4-step process, but the process fits around your existing ways of working. Okay, it's all about fitting something on top of how you currently work to encourage experimentation, okay, to encourage reflection and to help you to reduce uncertainty around decision making. Okay, so let's go through this, right? So step 1, you create a vision of success. You paint some picture of future economic prosperity. You paint some horror story of what will happen if you don't do it, you know, to give people like, a sense of urgency. And then in step 2, we need to understand our current conditions. So we need to analyze the available qualitative data and quantitative, so stories and numbers, basically. Third, we need to create a target condition. So by understanding our current condition, we know how far we've moved from our current, we know how far we've moved from the start towards our vision of success. And then once we understand that, then we can figure out an improvement milestone, okay? We can figure out some intermediary waypoint where we'll get some kind of gain in stability or throughput. We attach to that some success criteria and a time horizon. And then we experiment, okay? We iterate towards that target condition. We use the plan, do, check, act cycle by Dr. Deming. I've got to Deming in 9 minutes. And with the plan, do, check, act cycle, we want to run many different experiments in parallel. We try different technology and organizational changes, and then we create hypotheses. We see if they're actually working as expected. If so, we incorporate them into our baseline. If not, we try something else. So this is how you improve. This is how you get better. Now our question isn't how should we do continuous delivery. It's how do we know if we're improving, right? So this is all well and good, but how do you know what your vision of success should be? How can you understand your current condition? How do you know what you should be doing next? Should we be looking at stability or throughput? You know, it's hard to say if there's no data, you're just going to rely on guesses, okay? And then finally, when you're actually running experiments, how do you know if an experiment has been successful? How do you know if something's had a positive impact or a negative impact or no impact at all? So the answer to that is that you have to measure the stability and speed of your release process in order to reduce uncertainty and to make better decisions. So the good news for us is that all of the hard work, all of the thinking has already been done for us. Okay, so Nicole Forsgren, Jez Humble and friends over the past 5 to 7 years have been publishing the State of DevOps report. Each year it's a worldwide survey of thousands of IT practitioners, and they ask all kinds of interesting questions about the rate of deployments, rate of defect, that kind of stuff. And they found out all kinds of interesting things. They found out that the more often a company deploys, the more likely it is to exceed profitability, market share, and productivity expectations. And they've also published some peer-reviewed academic research that shows that as you improve throughput, stability is improved. And if you try to improve stability, then throughput will also improve. Okay, the two things improve together. It is not a zero-sum game. I know that for all of us, for the last 20 years, big IT companies have told us that you have to choose between stability or throughput. Those companies have been fundamentally dishonest with all of us because they wish to wallow in our money. Okay, luckily for me, I'm Cornish and I have no money. So I just trade vegetables with my neighbours. So why do we care about this? Well, the interesting thing behind the State of DevOps reports is that the same measures of stability and throughput have been used throughout. Okay? So when it comes to stability, Nicole, Jez and friends use failure rate, that is the percentage of changes that fail. They use failure recovery time, which is the amount of time it takes to remediate a failed change. And for throughput, they use lead time, how long it takes to make a change, and they also use frequency, which is how often you make changes. Right, so these pairs of measures form what's called clarification chains. They take something intangible, like stability, and they make it tangible. When it's tangible, it's something that we can measure. Okay? So there's a really awesome book by a guy called Douglas Hubbard called How to Measure Anything. And that's what this is all about, taking intangible things, making them tangible so that you can measure them. Now, these are measures. That means that we are assessing an event or a thing at a single point in time. All right? So that has some information value. That's of some use to us. But we can improve that information value by turning them into metrics, by measuring them at points in time. Okay, then we can understand trends, we can do some kind of pattern matching, and we can figure out some heuristics. But we can actually improve on that by creating indicators. So with an indicator, you take two related metrics like lead time and frequency, and you apply to them the same temporal properties. You measure them at the same rate over the same period of time. And then not only can you understand how they're changing over time, you can understand how they're changing in relation to one another. And it's also a single visualization, which makes it much more easily understood. So a couple of years ago, it occurred to me that we could apply these measures to production deployments, and we could turn them into indicators. So we have a deployment stability indicator formed of deployment failure rate and deployment failure recovery time. And we have a deployment throughput indicator composed of deployment lead time and deployment interval. And it also occurred to me that with the exception of failure rate, which is a percentage and a little bit of a funny thing anyway, we can measure average and variance. Okay, so with something like deployment failure recovery time, we can look at the median and the standard deviation, and then we can understand if an improvement is sustained or if it's just like a one-off flash in the pan. So again, that's all about increasing the information value of our measurements. Okay, so how does it work? So here is a generic technology value stream. So we write some code on a branch if we're not my friend, and then it goes on to master. And then we build it into a releasable artifact, and then there's probably too many test environments and too much end-to-end testing, and then we put it into production. And if it fails, then that's when our deployment failure rate gets increased, and the time between that failure and its remediation, we look at the median and standard deviation of that for the deployment failure recovery time. So with deployment throughput, you may be a little bit more familiar with these, how these measures work. So with deployment lead time, we measure the time from an artifact being built and being available for release and it going into production. And then we look at deployment interval as the median and standard deviation in time between production deployments. Okay, so in the continuous delivery book, very confusingly, both of these are called cycle time at different points in time. That's why I never use the phrase cycle time unless I'm talking to someone like Ozzy about cost of delay. And also, there was a talk yesterday, it's all a bit of a blur now, about value stream mapping. Everyone's like, yeah, I do value stream mapping. So I'm like, yeah, that's really great for finding out where you're losing time there, but it's pretty useless telling you about that, right? That's where you're losing all your time, between deployments, okay? Anyway, that's for another day. So it would be really useful if somebody had actually applied these indicators, right? Otherwise, this would just be my normal hand-wavy talk, lovely theory, and somebody would go, how does this work in practice? And then I have to stall until I can exit, and then come up with some kind of nonsense on Twitter about, how it all works, okay? So in this case, I have done it. For all you lovely people, I've worked for the past 2.5 years in a major UK government department. I can't say which one it is, but suffice to say it's one that all of us depend upon in our daily lives. And I was the team lead for an operations team. To come back to Phil Parker's excellent talk earlier today on organising for continuous delivery, I was the lead on an enablement team. We owned the deployment pipeline, and we helped our teams get better. We had 60 teams working on around 100 digital services, which were composed of 500 microservices, and they run in a secure multi-cloud private platform as a service. So now, whenever someone says this can't possibly scale, then it does. Okay, so I got the 60 teams badge, which is awesome. Okay, so in this government department, the technology value stream is quite simple, happily. There is an optional integration testing environment in case you just can't shake off those end-to-end testing blues. Please stop doing end-to-end testing. It makes me extremely sad. And there is a mandatory performance testing environment. All functional testing, exploratory testing, that happens locally on the tester or the developer's workstation. Okay? So my team came along with big ideas, and because I was team lead, there were lots of big ideas about continuous delivery. And we wanted to help our 60 teams start on their journey towards continuous delivery. But we had a couple of different problems. First of all, we didn't actually know how our teams were currently faring. For all we knew, all 60 teams were already doing continuous delivery, and we should all be sent home. We also didn't know, and you never really know in advance, but we couldn't see what the constraint would obviously be, okay? So yes, it's a complex adaptive system, you can't predict cause and effect, but as I said, we do have heuristics and pattern matching, and often in different organizations, similar constraints do pop up, okay? But in this government department, 60 teams use one automated release process, end-to-end testing is optional and discouraged for the most part, and teams are cross-functional. They have developers, testers, UX, UR, business analysts, product owners, the other one. They all work together, right, as a domain team, as Phil was saying earlier today. So all of those usual constraints that we might expect about handover delays or flaky releases or end-to-end testing, those weren't in play, okay? And on top of that, we didn't know which team needed our help first. And anyone that's worked at scale will know this is a very real problem. Should you help the team sat next to you that you're mates with? Like, come on, Steve, I need help with this thing. Should you help the team in Lincoln, who've been stuck on a pig farm for weeks and screaming for help with their build? Should you help the team in Fishguard that are just trapped in a cupboard smelling faintly of fish? And, they've never released anything. What do? I don't know. They must just be coding. Tell them to stop. Now, obviously that is fictional. It wasn't Fishguard, it was Aberdeen. But it is a very real problem, okay? How do you help teams help themselves when they don't know that they need help? Right? I know that's a little bit much for a Friday afternoon, but that is a thing. So the answer was we wanted to measure the rate of delivery across our 60 teams, and we decided to implement these deployment indicators. So first of all, we created a vision of success for all 60 teams, 600 people. And when I say we, I mean I. I waited till everybody went to lunch on a Friday, and I wrote a page on Confluence that basically said, everybody will deploy at least once a fortnight. They will do it in under a week. They can't have more than 1 in 20 production failures, and if it goes wrong, then they have to fix it in under a day. Now, these numbers might seem conservative to you, these numbers might seem aggressive to you, but it's about business demand in your organization, okay? And in this government department, this is pretty conservative, actually. But what we're really trying to do here is we're trying to divide our teams into 2 cohorts, okay? We're trying to find the teams, however many there might be, that are practicing continuous delivery as we understand it. And those teams, we want to learn from them, and we want to amplify their successes. And the other teams that are in discontinuous delivery, we want to dampen their failures and help them help themselves when they would like our help. So the way we started was by building an indicator service. The first thing you should do when you adopt continuous delivery is measure stuff. And I don't just mean any old stuff. I don't mean getting out Sonar or some other static analysis tool where you just drown in information that's pretty useless. I mean measuring the rate of delivery and how stable your delivery process is. So this was very simple. We had a deployments database already, which was really the important bit. So myself and another team member, we paired on some Python scripts. We sucked all the data out, turned it into CSV. I shoved it into a Google spreadsheet, created the indicators using Google Charts, and within a day or two, we had the information available, and it was sufficiently powerful, which we'll come on to in a moment, that I then got the go-ahead to actually build it out on my team, and then we built it out as a bunch of different microservices, and started rendering charts in real time on a website that was available to everybody across the whole organization. Okay? So we did that with some disks, some scripts, and some charts. There were no new clever tools, no new clever consultants. You know, we were already there, well, at least thinking we're clever. So no new crazy expenses incurred, okay? We got to new information very, very quickly. So when we saw the team-level deployment stability indicator for the first time, we were pretty surprised. We found a minority of teams were practicing continuous delivery. Over a 6-month period, their average deployment failure rate was 0%. And when occasionally they strayed from that average, they could recover in under a day. But the majority of teams needed our help. They had an average deployment failure rate of 10%. And crucially, the average deployment failure recovery time was 5 days. That is not great. Okay? So what does an indicator look like? This is an example indicator. This is a deployment stability indicator for a real team who are not called apples in real life, so hopefully they won't find out I'm talking about them. So this is a stability indicator. So on the left y-axis, we have deployment failure rate as a percentage, and on the right y-axis, we have deployment failure recovery time in days. We have to have the two y-axes because there are different measurement units. And the x-axis is just time. I've arbitrarily chosen a 6-month period for you lovely people. Now, the blue line is deployment failure rate, and the dark red line is the median deployment failure recovery time. Do we want the lines to trend up or down? Thank you. We got there in the end. What is it? Normally someone goes up really quickly and then we throw them out. You want it to trend down, okay? You don't want a high deployment failure rate. You don't want a high recovery time. You and I tonight, we're going to hang out, okay? So with this team, we had a deployment failure recovery time. They improved from 9 days to 0 days, and their failure rate improved from 20% to 0%. Okay? That's a pretty striking improvement over a few months. So we went to talk to the team. You know, we wanted to learn from what they'd done, and they didn't really know what they'd done. Okay? We made the mistake of saying, well, you're the best performing team on the platform right now, and then they strutted around the office for a while like peacocks. And I learned never tell a team you're the best. You know, it's all about them improving for themselves. Don't say you're number 1 out of 60, just say you're doing well, and never ever compare one team against another. So they did acceptance testing very well, which came in handy later on. But the interesting thing was that their monitoring dashboards were better than the other teams. We had a standard set of logging and monitoring dashboards that were fairly good. But they had someone on their team was really good with monitoring, creating some custom dashboards, and they were predicting and also finding problems in production much faster than other teams. They were minimizing that sunk cost of a defect between the activation point and the discovery point. So we exported their dashboards out as JSON. We wrote a little DSL around it to generate the same JSON for all of our other 500 microservices. And then we rolled that into production in about a day, and all of a sudden, everybody had the same really high standard of dashboards. And, you know, one bug fix benefited everyone, a change in the dashboards benefited everyone. So everyone reaped the benefits of this one improvement by this one team, and we wouldn't have known about that if it wasn't for this indicator. Okay, so with deployment throughput, the results were even more surprising. Okay, we had a minority of teams, and I mean a minority, averaging a deployment lead time of 1 day, and they went to production on average every 5 days. Okay, so we wanted 1 deployment a fortnight, and we've got 1 deployment a week. Okay, that's really good. But again, we had a majority of teams that needed our help. Their average deployment lead time was 12 days, and their deployment interval was 21 days. So they're deploying once every 3 weeks on average. Okay? One team had a deployment lead time of 3 months, and they had no deployment interval. What does that mean, please? Thank you. They did one deployment, it took 3 months, and then they decided to have a rest. And that was a bit hard, not do that again. Eventually, I found them, and I gave them a phone call, and they were like, "We've been waiting for you, Steve. You know, we thought you'd call." I don't know why they had a Cornish voice then. They weren't in Cornwall. Anyway, so here is our deployment throughput example. This is the bananas team. They did go a bit bananas. So on the left y-axis, we've got days. This is for both deployment lead time and interval. Again, time along the x-axis. Dark green is the median deployment interval, and orange is median deployment lead time. Is anyone in the audience colorblind, by the way? I have a friend in the Netherlands, a continuous delivery consultant who's colorblind, and I had to do different graphs for him and send them over. No? Just him, okay. Well, he's not here, sadly. Okay, so this team, they were deploying to production once every 3 days, and then it went up to once a fortnight. And we spotted this around April time, and we had a chat with them then. Would anybody like to guess the impediment that they faced, what their new constraint was? I'll give you a clue, you won't get it. WebSphere, no. Pardon me? Annual leave. Good guess. That's not bad, but it wasn't that. I'll try one more guess that will be wrong. Start the tax year. Oh, not bad, but no, wrong again. So we actually went and sat down with the team because they were in London. And when we sat down with them, we found out what the problem was. We didn't know any of them. They were all new. And I said, "Who are you?" And they said, "Never mind me, who are you?" And I was like, I said the worst possible thing. I said, "I'm Steve from the platform team. I'm here to help." And they were just recoiled. And of course, what happened is what happens every blue moon in London is the entire team decamped to go to some trendy music startup that thought, the best way to get to a really successful product is to pay lots of people lots and lots of money. And obviously, everyone then was new to government. They were new to the platform. They were new to this team. And they were actually doing a pretty good job, right? But you can't expect that kind of team to sustain one deployment every 3 days, right? Things would break. So they fell back to once a fortnight, and they did that for a while they got up to speed with their service and with working in government, okay? So the lesson here is that there's a thing called a ludic fallacy, which comes out of Nassim Nicholas Taleb's work. The ludic fallacy basically says that you cannot and should not predict qualitative outcomes from quantitative information. In other words, you can't know what the story is from numbers. Okay, you have to actually go away and find out what it is. Okay, so an indicator is not about telling you what happened. It's about pinpointing where you need to go to find out what happened. Okay, it doesn't give you that new information. It tells you where to go and look for it. All right. Okay, there's more. So it occurred to me a while ago now that these original measures from Jez, Nicole, and friends don't actually specifically apply to deployments. We can reapply them to different aspects of the technology value stream in order to better understand the process. Okay? So, builds, for example, continuous delivery insists that you have an always releasable code base, and that is something that's very hard to accomplish. So it makes sense for us to manage build stability and build throughput, and to do that, then we need to measure them. So we can use exactly the same measures, failure rate, failure recovery time, lead time, and interval, in order to understand how fast we can build and how stable our builds are. Okay? So, as you'd expect, build failure rate is the percentage of builds that fail on the build server, and build failure recovery time is the median and standard deviation in time between something breaking on your build server and it getting fixed. Build throughput is build lead time is the median and standard deviation in time between a commit onto master and its subsequent publication as a releasable artifact. And build interval is the median and standard deviation in time between artifacts being created. And again, don't let that little line fool you. Lots of time is being lost to there that will not show up in build lead time. Okay, so for builds, we divided our teams up into two cohorts, those that are building frequently and those that are not building frequently. And we simply asked that you be building at least once a day in under an hour, and when it goes wrong, 1% of the time, it takes you less than an hour to fix it. Okay, so we had a tiny minority of teams that were building frequently. I believe off the top of my head it was 3 teams, and one of them was the Apple's team. So we got a build failure rate of 0% and a recovery time of under an hour, but the vast majority of teams, 1 in 5 builds failed, and it took them 4 hours on average to fix it. One particular team had an average build failure recovery time of 12 days, which is an awfully long time for Jenkins to be read. I expect they just went on holiday for a while and hope Jenkins would just sort itself out. So this is an example build stability indicator. This is the grapes team. So again, on the left y-axis, we have a failure rate, and on the right y-axis, failure recovery time for builds. The purple line is build failure rate, which is low and we shouldn't worry about. The dark blue line is interesting. That's median build failure recovery time, and that's hanging out pretty static at 10 hours. Now, if you went to Ozzy's talk yesterday about cost of delay, she talked a lot about product development and flow. It is a stochastic world up there. Things are constantly changing. If this team wasn't doing any builds, then there'd be a break in this line, right, to show inactivity. When a line is that static, then something funny is going on, and I don't mean with computers, I mean with people, okay? Because that shouldn't happen, right? Your build time won't be that static, okay? So we spoke with the team, and what we found was something quite unusual. Their acceptance test took 10 hours, pretty much dead on, and they were so put off by that build time that what they would do was they would create their release artifact and then run the acceptance tests afterwards. And if they failed, they would go back and fix it and build it again. Okay? So they're pushing a risk down into the value stream that they shouldn't, but also there's less incentive for them to speed up their acceptance tests because they've pushed them away from their daily working practices. Okay? So we actually pinched someone off from the Apples team, parachuted them, metaphorically, into the Grapes team to help them speed up their acceptance tests. And surprise, surprise, they had loads of UI tests, beautifully written in Selenium, doing lots of field validation, lots of other things that were unit tests, and lots of testing of business expectations that could have been done with an API. And I think within a couple of weeks, I think the team had dragged it down from 10 hours to about 1 hour. And that was when I really started sitting in the team lead's lap and whispering in their ear about writing a blog post to share across the whole organization. Say, look, we went from 10 hours to 1 hour and you can do it too. And like all ghostwriters, nobody suspected a thing except for the fact it was clearly written in my style. It's far too lectury and dry. Next time I won't be the ghostwriter. But the main thing was that amplifying of success and that sharing of information across the whole organization. Okay, so with build throughput, we had, again, every team had 0 hours, under an hour, for their average build time, which was really great. But the build interval, there was a huge difference, okay? A handful of teams were building every 2 hours on average, but the vast majority, it was every 2 days. Okay, so that's a lot of teams that need help with their builds. Okay, so this is the build throughput indicator. This is the oranges team. So we have days on the left for lead time and interval, and as we just heard, every team was averaging a build lead time of under an hour, so that dark yellow line is not of any interest to us. What is of interest is the red line, okay? So at the start of this time period, the team are building once every 4 days, and then in 1 month, they improve to building once a day. And then over 5 months, they regress to building once every 4 days again, okay? That's not continuous delivery, all right? That is too fast. Do you remember what I just said about when things look too good to be true, then they probably are, right? That is a team building more quickly than they can sustain. And actually, their build stability showed an increase in build failure rate. Well, there's a correlation there. It's not cause and effect. But it was quite striking. Okay, so I, under cover of darkness, spoke with their team lead. This was actually one where I did suspect I knew what the issue was, just from bitter experience in IT. And the product owner was pressuring the team. They had a deadline. And, there was a gun to the head of the team, not a real gun. There are no guns in government. But the team was under pressure to deliver in February to hit a business event, and it was basically, you have to do more testing, you have to do more builds. And they cut some corners, they cut down on acceptance tests. They got there, but after the business event, there was no incentive for them to continue at that speed. So they naturally let it slide back to something that they were more comfortable with. So this was actually quite difficult. We spoke with the product owner, showed her the graph and said, look, this is not great. If this was your production deployments, then we'd have more production problems. We spent some time with the team, helped them improve their acceptance tests, and helped them start to do more frequent builds but at a more sustainable pace after this time. Okay, so finally, I've decided to measure continuous integration as well. So for many, many years, people in the continuous delivery community have known, I think, that you can't do continuous delivery without continuous integration. And happily, Nicole, Jez, and friends have actually shown in their most recent work that continuous integration is a statistically significant predictor of continuous delivery. So continuous integration is not a tool. I have to say this every year. Continuous integration is not a tool. Okay, it's a mindset. It's about every member of the team committing to master at least once a day. Okay? Now, it stands to reason if everyone is committing to master frequently, then you are capable of building frequently. And if you are capable of building frequently, then you have the opportunity to deploy frequently. Okay? It stands to reason if a team is in continuous disintegration, if they suddenly say, we're going to do continuous delivery, then that's a team to watch from a very safe distance. Okay? Because they will not be able to do it without errors occurring. Okay? So we can't really measure code stability because, when you fail to commit something to master, it happens in your local checkout. There's very little reporting centrally. But we can measure throughput. We can look at mainline lead time. That's the time between you committing a change to a remote branch and merging it to master. And we can also look at mainline interval, which is the time between commits to master. Okay, so that's what that looks like. Yes, all well and good. So this is actually really easy to do because all you have to do with a mainline throughput indicator is basically query your version control system over an API or local checkouts to understand your commits. And continuous integration has our success criteria all laid out. Okay, we know that every team member has to commit to master at least once a day. So all we have to do is say mainline interval needs to be less than 24 hours, and the mainline lead time between branch and master, ideally, it's going to be less than an hour. Okay? So we had some shocking numbers on this, really, really surprising. Okay? What was really interesting was that all 60 teams averaged 0 hours between between a commit to a remote branch and then merging into master. Okay? But do you remember what I said a while ago about looking at average and variance? Okay? Everyone had a just dandy average, but there was some crazy variance. Okay? And one kind of signal of that was in the mainline interval. Okay? 2 teams averaged like 2 hours. Okay? Between commits to master. That's excellent. All right? But 58 teams together averaged 5 days between commits to master. Okay? So there are some teams right there that are a long way from continuous delivery. There are some teams there that are deploying pretty often, yet their commits to master suggest that there are going to be problems. Right? So this was a very, very interesting new piece of information for us. Pardon me, did they use any kind of pre-commit? Code reviews. Okay, oh, that's a good question. I should have said that. Thank you, thank you. So now you're going to make me say something on video, and I'm going to have to hunt it down on YouTube and scrub this bit out, okay? So I was one of the people that chose the branching strategy used, and I did not mandate trunk-based development, which, knowing me, you might expect. I need to phrase this very carefully for posterity. My children will see this one day when they're grown-ups. I asked teams to at least use GitHub Flow, i.e. pull requests in under a day, and at best do trunk-based development. I felt that asking 60 teams to do trunk-based development was going to be a bit of a stretch. Okay, so let's say for simplicity that all 60 teams doing GitHub Flow. Okay, so yes, there's a code review process in pull requests. Does that answer your question? Yeah. Okay. Correct. That's right. Okay, but also teams of pair program, which is the best way to do code review, because then you have constant code review. Okay. Some teams, including the Apple's team, were doing trunk-based development, so that meant that their mainline lead time was always 0, and it meant that they could be friends with me because they were committing to master as often as possible. Okay? But this was the 5 days thing. That was like a real surprise. Okay? So here's our final example indicator. This is from the pairs team. I have never eaten a pear since. This was a very, very difficult situation. So the team, so as you remember, my team was responsible for the deployment pipeline, the build server setup, and this team asked us to create tooling so that they could build branches on the build server. Now, continuous delivery teaches us that that is not a good idea. It will discourage you from integrating more frequently into master. So when we very politely said no and gave an explanation why that wasn't a good idea, it would be fair to say that the team lead was quite sad. But then I reached out to this person, I spent some time with them, and together, which is a crucial point, I didn't like do this one in isolation, I did it with that person. We measured their mainline throughput by doing a massive analysis of GitHub, okay? Now, with this, you can see that the dark blue line is their median lead time from branch to master, and that goes from 0 to 34 hours over 6 months. Now, the reason you can't really see that is because the y-axis is insane, and that's because their mainline interval increased from once every 4 days to once every 27 days, okay, over 6 months. Now, without being snarky or jokey or whatever, this is clearly a team that needs help, and they don't need someone to descend on them from that London, where they have those sausages and those unicorns, saying, you need to commit more often, right? That's just not going to work, okay? They need support, not control. And the team leader and I had a chat. I travelled up to north of England to visit them. And they said that they had been told by a different architecture group that I didn't actually know existed, that they had some major architectural changes that they had to make. And at the same time, they had a product owner saying, you have to ship to get my features in, right? To carry on making cost savings for citizens. So Phil today mentioned about matrix management. They were in matrix management, which is never a good idea. And obviously, if you're an inexperienced team, if you're told make these big changes and keep shipping, you will do long-lived branching, right? Because that's the only lever that you know of, okay? Because the tool gives you that lever. You don't have to do any thinking at all. And the tools are very seductive these days. So what we did was we sat down and we talked about feature toggles. We connected this team lead with the team lead of the Apple's team, because the pairs team lead was like, we can't do feature toggles in government. And then when I said, who says, there's no policy on that at all, it's all good. And the Apple's team lead was like, yeah, we do it all the time, there's no problem at all. Like, you look at my code, it's dead easy. So they started to use feature toggles after this time. Slowly, very slowly, that mainline interval came down. And they had a really glorious thing happen where they had a production incident where the third-party system they used became unavailable. They did that thing where they sent an email saying, we're going to have emergency maintenance in 30 minutes. And when their product owner started doing a bit of a Roadrunner impression, one very bright person on the team said, why don't we just toggle off that connector and just return dummy responses to citizens for a while, and then our service can stay up, we can keep making cost savings for the government, and everyone's happy? And that worked really well, okay? So they learned a better way of managing their code base, and they got improved operability of their production system as a really beneficial side effect. Okay, so let me wrap up a little bit. So I've shared with you the indicators and some stories from a 3-year, 60-team continuous delivery program that has gained some real traction. Measuring continuous delivery did not and could not tell us what decisions to make, but it did tell us where to go to find the stories and get the new information that would help us make better decisions. Automating monitoring dashboards, using feature toggles, encouraging better acceptance testing, that all came out of single improvements that single teams made that we then replicated across different teams, okay? This approach worked with 1 team, 6 teams, 60 teams, okay? Very easy to implement, okay? It's just about finding the signal out of all the noise, all right? So continuous delivery is valuable, continuous delivery is hard, it's only going to become harder, it's only going to become more valuable. You should use the improvement charter to incrementally and iteratively improve towards satisfying business demand, and to drive the improvement charter to get that new information out of your organization, you need to measure continuous delivery. So thank you very much, and I'm happy to take questions.